Good afternoon, everyone. Very good to be here. I must say it's a little bit humbling for me to follow that last presentation. It brings to mind the term hard act to follow. As the son of a soldier, I really very much appreciate what those guys are doing, and it's a little bit I have this lamentable image of somebody standing with these guys in a conversation. Someone said, well, what do you use Bayesian networks for? Well, we help soldiers survive and win in battlefield conditions. What about you? Oh, things like sell more candy bars. But it does tell you something about the wide applicability of BayesNets and what can be done with Bayesian network modeling and how many fields this can be applied to. Anywhere where there's uncertainty to be dealt with, there are decisions to be made and supported, these tools can be brought into play. I'm going to talk to you today about the use of Bayesian networks to model what we call key drivers analysis in marketing research. This presentation was actually first given at a symposium that my company put on for our clients, so it really was designed for a rather different audience than this one. Certainly the average level of analytical and methodological sophistication of that audience was, shall we say, not on a par with this one. So some of this may seem a little on the simple side to you. I apologize for that. But maybe it'll give you some feel for at least how one team has gone about trying to frame the usefulness of BayesNets to clients in a field where the client side is not, trained in this kind of stuff. It's not their job to know about these kinds of things. They just have decisions that they need to make and make them more effectively. And this is another tool that can be brought to bear. And we need to tell them why and convince them. And as compared to methodologies that have heretofore been more traditionally used in marketing research, I think BayesNets are a great deal more powerful under many circumstances, but the reasons are very technical. And these are not technical folks. So it's kind of hard sometimes to get across what we call the reasons to believe, if you will. And this was one attempt to do that. So, page down. Okay. First off, Bayesian networks for use in key drivers analysis. What is key drivers analysis? Well, it goes under a lot of different names, but it's basically this. And this is just a pointer. It's not going to advance it for me. Hey, I'm not nervous, though. Not at all. So we have some market attitude or behavior, what we call I call the targeted outcome. Okay? And it's an attitude or behavior out there in the marketplace, in the real world, that we need to, two things. We need to favorably influence this marketplace behavior, but we cannot influence it directly. Okay? So a lot of times it's as simple as get them to buy our stuff instead of our competitors' stuff. That's the behavior that we want to favorably influence. But you can't just ask them politely. You could do an advertising campaign, please buy our stuff instead of our competitors' stuff, but obviously, even if you use the announcer with a really polite-sounding British accent, it's probably not going to work, right? You have to find you have to find those best levers to pull, metaphorically speaking, through which you can indirectly influence this attitude or behavior. Things that you can influence, which in turn will influence the target outcome behavior. And these, in marketing research, these usually boil down to customer attitudes and perceptions about your brand, about your product, etc. The logic being, if you can influence those to become more favorable in the mind of the average consumer, then that's going to move the needle for you on the target behavior that you're trying to move ahead. So as I say again, things we can influence directly through product, service, design, or marketing, and things that will have what we call strong derived importance. Okay, and that's just marketing research speak for associational value, correlation, if you will, joint probability in the Bayesian term. All right. Derived importance means, well, we find that it correlates with a measure of this targeted outcome. People who feel this way about our brand are significantly more likely to buy our brand than a competitor's than are people who don't feel this way about our brand. Derived importance, okay? So the purpose of key drivers analysis is simply to empirically identify what are those best levers to pull. So, given the audience that I was speaking to when I first gave this presentation, I felt it necessary to kind of make the following point, the point that I'm going to make with this slide. And I think this slide is a large part of the reason why Stefan asked me to come give this talk, because A, he loves cars, and B, he's German. Okay? A lot of times in marketing research, and especially if you're a marketing scientist, you feel this, you're dealing with folks who a lot of times don't want to be bothered with the nuts and bolts, the mechanics under the hood. They just want to know what's the outcome, what are we supposed to do. And this perspective can sometimes lead to an attitude, or shall we say, a lack of appreciation about technical differences between one technique versus another technique. And again, Bayes nets is something to really understand why it's better. You kind of have to know something about the technical differences as compared to, you know, the advantages that derive out of analyzing joint probability distribution hypercubes as opposed to bivariate covariance matrix, things like that. You know, you want to make a client's eyes glass over, use a phrase like that. But we got to get the point across. So I used an analogy that, you know, sometimes things, you know, not all useful objects are outwardly shiny objects. Okay? What's this? This is a 1968 Volkswagen Beetle. Those of you of my vintage will remember these. They used to be quite prevalent on the road. This is a 1968 German Federal Police Cruiser. Okay? Now, I know about this because, as I say, my dad was a soldier. He was an Air Force fighter pilot, actually. And we were stationed in Germany in the late 1960s, around 1970. We used to call them the white mice. You know, they'd be driving around. And people would think, God, what are they using a VW Bug for a police car? You know, they couldn't catch an old lady on a skateboard. What is going on here? Well, again, what you see is not necessarily what you get. This is the engine for your stock VW Beetle. All right? This is the engine that was in the German Federal Police Cruiser. As you can see, it's made by a different company. And along with that Porsche engine, there was Porsche transmission, you know, Porsche suspension. I mean, you did not want to try to run from one of these cars. Okay, you weren't going to win. So outward appearances can be very deceiving. And the moral of our story here is that what's under the hood matters a lot, even if you can't directly see it, or if maybe you don't understand it because it's not your area of expertise, it might still make a big difference. And so this is the comparison I'm making here. On the left, we have standard drivers analysis using things like bivariate regressions and stuff like that. And on the right, we have Bayesian network modeling as applied to key drivers analysis. So what are some of the problems with traditional techniques that we traditionally use in key drivers analysis and marketing research? Well, there are different methods that are used. They mostly boil down to derivations of different regression techniques, or even more basically bivariate correlations at times, but they're all analyses of covariance. They're all looking at covariant structures in a sense as opposed to joint probability distributions. This brings up some pragmatic problems. The biggest one, we've already talked about some today, is the major bugaboo of multicollinearity. All right? What is that basically? Well, let's kind of move it along. There's probably nobody here who doesn't know what multicollinearity is, so I'm just going to move this kind of quickly. It's basically what you get when you have a high average degree of correlation between your independent variables, or your predictor variables, or as we call them, the drivers, the potential drivers. Keeping in mind this is a lot about prioritization, right? We've asked in this survey, we've asked about 25, 30, maybe even more brand perception attributes to gauge how consumers feel about your brand versus competitors' brands. You want to prioritize. You want to find out what is the smaller subset amongst those attributes that really matter in the sense that they can serve as effective levers for us to pull to move the needle on that targeted outcome behavior that we cannot directly influence. We can't focus on all 25 or 30 of these. You'll just create confusion in the market. You have to find out which ones really matter. Well, unfortunately, a lot of times you'll find that there's a great deal of correlation between a number of these, okay? And sometimes, you know, and multicollinearity is not something you either have or you don't have. It's a matter of degree. So like in this situation here, that's, you know, really bad because the two circles here represent our two independent variables, and they correlate almost entirely. And both of them therefore correlate very similarly with our dependent variable, which is the measure of that target market outcome that we want to be able to influence. Down here, this is excellent. We have no multicollinearity. But it's still a little bit of a problem for reasons I'll delve into, that these two, even though they're not correlated with each other, they're very similarly correlated with the dependent variable, right? And then you have various shades of multicollinearity in between. And the more the multicollinearity, the greater the problem you're going to have in trying to parse out the effects of one driver versus another. In marketing research, with our survey analyses that we do, we typically I think we typically run into situations where it ranges from the really bad to bad is not at all unusual. Especially with, there's a certain type of market research survey called a tracker survey. This is where you do the same survey periodically to track things over time. And for reasons we haven't entirely proven, they tend to be particularly vulnerable to multicollinearity. Another drawback with drivers analysis, as it comes from typical regression techniques, is you don't capture interaction effects very much. Part of the reason for this is because that a lot of times in trying to deal with the multicollinearity problem, people will silo this. They'll break it into different regression exercises, if you will. And that helps, in one way it might help with your multicollinearity to the extent that you have correlations across these silos, but two problems. One, it's kind of illogical because you're probably siloing these based on some sort of themes or subject matters, and you're probably therefore going to put things together that are more likely to be multicollinear because you're asking about the same general topic. But the other problem is you're cutting off any possibility of understanding the effects, the interactive effects of these dependent variables and how they may combine in a holistic sort of way to influence the dependent variable that you're trying to understand. But Bayes nets helps you get around both of these problems. It helps you basically kind of blow them away. They're not problems anymore. So, again, I was speaking to a relatively much less sophisticated audience than this, so we just went through an explanation to make sure people understood why is multicollinearity a problem. We understand that what it is, it's high correlation between your predictor variables, your independent variables, but why is that a problem in key drivers analysis? Well, let's look at multiple regression. Standard stepwise multiple regression as one technique that someone might try to use for drivers analysis. You're bringing in the independent variables one at a time. The procedure starts by finding the independent variable that is most associated with the dependent variable, and then it works from there. Now, in a situation like this one, we have two independent variables we're thinking about for purposes of explanation here. This is, imagine a rating on your store experience after you've gone into a clothing store or something. You rated employees were helpful, how employees were helpful, how knowledgeable were the employees. And your dependent variable is this experience quality rating. You want people to feel like they had a good quality experience, so they'll come back, they'll recommend your store, et cetera, et cetera. But again, you can't say, please feel like you had a good experience here. You have to find ways to create that outcome. Well, these two independent variables, as we're illustrating here, are pretty associated with each other. That's this area here. And you can see where that would make sense. If an employee is knowledgeable, they're going to be more helpful. If they're more helpful, you're going to tend to think they probably were more knowledgeable because you're going to feel favorably about them, right? So these things will tend to associate. So this is the variance in the dependent variable that's accounted for by association with employees were helpful. This is the variance that's accounted for by opinions that employees were knowledgeable. Okay, and I tried to illustrate this, right? But this is just a little larger football than this one, all right? But they are almost identically associated with the dependent variable. The problem with multiple regression, stepwise regression, is that what it's going to do is it's first going to say, okay, here's the one that's slightly more associated with our dependent variable, and it's going to take all of this variance that can be accounted for statistically by association with this dependent variable, and it kind of pulls it aside. It's accounted for. Move it aside now. So only the remaining variance is left over to be potentially associated with others of your independent variables. Well, this is, say, our second most associated independent variable, but now it's only this smaller part of its overall association is now available for it to sort of grab onto. So stepwise multiple regression is going to tell us, okay, big driver here. This is the one really to go after. Not nearly so strong a driver here. When in actuality, we know that now they're really both very similarly associated with this dependent variable. And to make it worse, if you're doing a tracker, you come back next quarter, and because of random variations and sampling and what have you, situational reverse. And now this time, this one will have the slightly greater correlation with the dependent variable. So now you're coming back and you're saying, well, 3 months ago, it was really employees were helpful and sort of employees were knowledgeable. But now it's really employees were knowledgeable and sort of employees were helpful. And the average client short circuits when you tell them something like that because they're not believing that things have changed that much in 3 months. And indeed, they're right not to believe that. things haven't changed that much. Your technique is just very subject to being confused by this effect of multicollinearity. So that's what multicollinearity is, and that's why it's bad. So one way that, as I said, that marketing scientists have tried to cope with this in the past is to do this siloing, especially when you have clients, and you run into this a lot, who have what I call the JIC approach to attribute batteries design, the just-in-case approach. Okay? So think everything you can think of that might remotely be related to this and toss it into that survey, all right? Yeah, but more than 20 minutes in the survey, the data starts to decline in quality. They don't care. Throw them all in there. We want to make sure it's just in case. So you can end up with lots of attributes. So this siloed regression approach has been tried, where, like I say, you break them up into groups of attributes, and you deal with them with intermediary dependent variables, and then those feed in, and you try to kind of ladder up to it. All right, some degree of logic to it, but it's still going to be the case that you could have significant multicollinearity within each one of these groups. And to the extent that you've organized them by some thematic scheme, it's likely that you might be actually increasing the likelihood of having multicollinearity within the groups. And so that's one problem. But then there's also the fact that you probably have interactions across these groups, right? It's very possible that speed of ordering could influence customer service perception. It's very possible that, I can't read, what is it, greeted by the employee might influence the overall atmosphere-dependent variable. So you can have independent variables for one group that logically in the real world, in this complex, interactive, dynamic system of influences that actually occurs in the real world, not quite nature, if you will, it's not Mother Nature, but it's the marketplace, and it's real, and it is interactive and dynamic in that sense. These things are actually happening, but this mode of analysis is not going to catch any of those effects. You're not going to get any of those, what we might think of as indirect effects, for example. And then you could also have all kinds of interaction between variables across the different silos. And again, those can create indirect effects that we would like to ideally be taking into account as we try to understand what lever to pull, because a lever can have direct effects, it can have indirect effects. Sorry, I'm mixing metaphors quite a lot here, but you get what I'm after. So it doesn't work all that great. One thing I might mention here, when you take this logic to its extreme, you end up with what has become a pretty widespread approach in marketing research industry to this. And what you do then is you say, well, hell, let's just do them all one at a time. All right? But you don't call them two-way correlations. Instead, you refer to them as, you do bivariate regressions, which to a layperson sounds a lot more scientific and maybe a lot less vulnerable to the problems. And yeah, you've eliminated the multicollinearity, but you've kind of created another potential problem. If you think back to the Venn diagram that I showed, those two independent variables were very similarly associated with the dependent variable, excuse me. And so while it's good that you want to know that, when you deal with a lot of multicollinearity, as we typically run into in market research surveys, when that gets too extreme, you can come out with the conclusion from your bivariate regressions that, well, everything's important and kind of similarly important. Well, again, as I said earlier, the objective here is to prioritize. If I've got 20, 30 attributes that I'm dealing with in a survey, and I come back and tell the client, well, they're all correlating roughly at this level, or the great majority of them do, or 20 of them do, I haven't helped them prioritize enough, because they can't commit resources in product design and product marketing against all that diverse array of attributes. They need to find out really what are the actionably small subset of attributes that we can work against. So going to the extreme of defeating multicollinearity by just breaking it out into bivariate parts doesn't really meet the objective either. And of course, that totally removes any opportunity to understand how the interactive effects between your independent variables might be coming into play to influence the independent variable, which again is what happens in the real world. And so we'd like to be able to model that if we can. So the former best approach when you're trying to deal with all these things was thought to be structural equation modeling. Probably most of you here are familiar with this to at least some extent, so I won't get into what it's about at a technical level. But it had some drawbacks. I'm sorry, I'm getting ahead of myself. Siloed regression tree. We talked about this a little earlier. Just to recount the problems that it does enforce kind of a simplistic structure, one that is a priori in its definition to the extent that you're deciding what these silos are going to be. It's only accounting for direct effects for the most part, and it's pretty diagnostic and descriptive, more so than being prescriptive, which at the end of the day is what we're really after here. Again, what can we do to influence what happens in the marketplace? Then came structural equation modeling, something that we thought this might be somewhat better. We can test more complex structures. We can start trying to get at interactive and indirect effects, and it's more explanatory and prescriptive than the siloed regression approach. However, it is still subject to potential multicollinearity problems because most structural equation modeling is based on, again, it's analysis of covariance structures, and that's the source of multicollinearity. And it can only test the fit of specifically hypothesized networks. The great majority of the tools that you can use for structural equation modeling will let you posit a model. It's as if you're using BayesiaLab and you draw in all the arrows, all the arcs, choose the directions. The tool will tell you to what extent this seems to fit the data with something analogous to a statistical significance test. But if it doesn't work too well, then you have to think, okay, what do I have to change? Try it. See, it's kind of a trial and error process of trying to get to the best network. Whereas when you have a tool like BayesiaLab with its machine learning algorithms, you can get much more quickly and much more confidently to a network structure that you can feel better about. Yeah, I think this is representative of that data generating model that we're trying to find here. And there are good tools there to really help you compare one model against another. You can get much more quickly to what is probably a superior solution, because you can hunt and peck with that structural equation modeling tool all you want, but there's a good chance that out of the many, many solutions that are possible with this data, you may not find the one or even one of the ones that is actually best to the purpose. Having a tool like BayesiaLab available really increases your probability of getting to a strong model of what's actually generating the data in the real world. So Bayesnet's key drivers analysis, as an example, we talked in terms of, we told them about a project we had done, this customer satisfaction surveys with over 650,000 retail customers. They were conducted throughout the year 2013, asked about their overall quality of the in-store experience that they had, and then also rated that experience on a number of particular independent variables. And this was, I'm not going to get into a lot of detail about results here. We were basically just trying to anchor this to a real-world situation that most of our clients in this audience would be able to relate to. And just remind them, what are we trying to do? We're trying to move the needle on this attitude of overall experience, perception of overall experience. What was the quality of the experience I had in this store? Because again, that affects things like likelihood to return, repeat business, likelihood of recommending, etc. And with a tool like Bayesnet's, you can get, for all these various attributes, you can get not only the direct effects, but you also get an understanding of how all these things interact within each other. I realize this is a way overcomplicated network, but this was for purposes of illustration more so than anything else. So again, here I was just trying to illustrate the scenarios under which this is particularly useful, but the difference that you can encounter is really best appreciated if you actually have a chance to work with a particular data set, for example, that really has these problems, like multicollinearity. A few months ago, I had the opportunity we had a tracker that had been going for a major client for a long while, and it was getting to be some concern to us because they were, suffice to say, they were questioning, are we really getting our money's worth out of all these tracking surveys? Because it's a good retrospective rating tool. We can see how well we're doing on things, but it's not helping us to really drive through the windshield instead of looking in the rearview mirror. We want to know, in a forward-looking sense, what can we do to further enhance the power and the effectiveness of our brand in the marketplace? And that's where drivers analysis comes in. But again, this was a tracker, and trackers are just notoriously ridden with multicollinearity as a problem. So we had been trying to use more traditional techniques to get some good drivers analysis results out of this data, but it was giving us the kinds of problems that I was just describing. This was about the time that we were bringing BayesNets and BayesiaLab in particular online as a tool to use. And the general manager of this business unit reached out to me and said, I understand we have this new tool. Do you think it might be helpful here? Let's give it a try. So we took that same data, the exact same data that had been giving everybody fits for months, and used BayesiaLab to, first stage was we used BayesiaLab variable clustering to take these several dozen attributes and boil them down into coherent underlying themes. This was very successful because whereas we had previously, with standard factor analysis, we had been getting a solution, I think the default solution had like 5 or 6 factors. But this is like 65, 70 variables. And the first factor was this kind of mega garbage factor. I mean, there's just all kinds of stuff coming into this. And you looked at it and you knew this just can't be right. There has to be, greater differentiation than we're seeing here. And, of course, what's going on there is the multicollinearity can confuse factor analysis as bad or worse as it confuses stepwise regression, for example, because it's just an analysis of a matrix of bivariate correlations. And all the factor analysis routine knows is, well, this stuff is all correlated. And it's more correlated with each other than it is with anything else, so it must all be part of one underlying construct. When in actuality, you have things like brand halo effect. You have respondent scale usage biases, things that tend to result in this artificial appearance of a single underlying theme, if you will. Well, because BayesNets and BayesiaLab in particular leverages joint probability distributions and gives you also different algorithms on the basis of which to run your factor analysis, you can fine-tune the analysis and you can adjust the parameters of your investigation. So in this case, we found that using a maximum spanning tree algorithm from BayesiaLab as the basis of the factor analysis, which I understand you had something to do with that, right, Michael? Yeah? These are the two guys right here when it comes to maximum spanning tree for factor analysis. It came out not a 5 or 6 factor default. It defaulted to about 15, 16 factors. I looked at the dendrogram, paired that back to about 13, if I recall correctly. Really, really great. By the way, being able to match the colors and change the colors in the dendrogram, that would be so cool. It really would. Oh. Okay. That's embarrassing. That's embarrassing. But so what we end up with is this maximum spanning tree network where, the colors are showing the different factors. And you show this to a client and they were like, there it is. That is the map of our market's mind. Because here not only are we seeing the factors nicely illustrated in terms of what nodes connect with what nodes, but we're even seeing these uber factors. Because we can see up here in the corner, here are these 3 factors, and yeah, they're different, but we look at it and see these all have to do with things related to kind of like corporate image. There's corporate responsibility, treat your employees well, things that go together. So you got this where before you just had this morass of factors that just weren't making sense and you couldn't force them to make sense. Now you have this clear, intuitively appealing map of how the market's mind is organized in terms of the themes that underlie attitudes and perceptions towards brands in your category. That's a big, big improvement. And now we can take those factors and we can network them in against the dependent variable. We can use target dynamic profile, for example, for optimization to understand because again, we're trying to get to priorities here, right? It's great that now we know what these factors are, but we also still want to know which factors represent levers we can pull that will move the needle on this target market outcome. Well, we derive a network using the latent factor variables, use target dynamic profile to help us to prioritize what are the more versus less impactive factors in driving our dependent variable. That optimization approach is taking into account not just the direct effects, but the interactive effects between the factors. This is great. This was all pipe dream stuff before this kind of tool was available. It's really, really very powerful, especially when you're dealing with this certain kind of data that just wouldn't cooperate using traditional parametric approaches and methods. So it helped us. I mean, we were talking about a major, major client here. I won't say who it was, but you would have heard of them. And they were thinking in terms of pulling, way into 5 figures worth of business because they didn't feel like they were getting enough forward-looking utility out of it. Now we're getting to a place where, oh, okay, yeah, now this is helping us to drive through the windshield. Now this is helping us to find the metaphorical levers. And this with the same data with which they were thinking about, maybe this isn't worth our money. Now it looks like they're thinking, okay, now you're really pulling the actionable information and knowledge out of the data. I so often quote Peter Drucker from a book of almost 30 years ago now. Hardly a week goes by in this business that I don't have an occasion to quote this. And he said, data is not information, and information is not knowledge. All right? Data is just data. Most of it is noise more often than not. You have to mine information out of data by applying the right kind of analysis to produce actionable insights and understandings. And then when you do that well enough, you cross this magic line where information becomes knowledge, and that's information that makes you capable of better and more effective action moving forward. So what I've given you here is just an example in a particular application in a particular field of how Bayes nets and BayesiaLab can be used to do a better job of pulling that information and knowledge out of a data set, even when it's data that, because it's observational and you can't manipulate, you can't do it as an experiment, it's messy. It's messy and it's multicollinear, but we can still mine actionable information and knowledge out of it. This really is, I think this shouldn't be called data mining, That's like saying we're after gold, but what we do, we call it dirt mining. All right? We're knowledge mining. We're trying to mine information that makes us capable of better and more effective action moving forward. And that's as much about the tools you can bring to bear in analyzing and understanding the signal in the noise as it is about the data that you can pull in. This was just one example of how this particular tool set can really help you to do that. I think that's all. Oh, this is just some output from take a target dynamic profile, pull it into Excel. I love color conditional formatting. When, I think it was Office 2007, I think it was, when they actually made the gradients here, and they also expanded the worksheet size to over 1 million rows, and changed my life. That says something about my perspective on things, doesn't it? But if you haven't used this before, it's one of the cooler things amongst many cool things in BayesiaLab. And basically, this is just telling us here that we're trying to optimize. We want to figure out what do we need to focus on first and foremost, and in what order of priority, in order to get more customers to feel like they came out of that store having had a good experience. This was good. I'm going back. I'm telling my friends, this is where I'm coming to get my clothes. And we want that to take into account interactive effects as well as direct effects. And this is just output from that actual analysis. Some names have been changed to protect the innocent. This basically, said, okay, first into it is employees acknowledged and made you feel welcome. All right. And again, here's the target outcome that we want to maximize. What we're seeing here is what that mean on that target outcome will be on a 10-point scale as we move through the optimization process. So we start with the first independent variable that came into play, and this is just telling us, okay, at time t, you had a mean of 8.3 on this one, but if you could push that up to 9.3, 2 things would happen. You'd get an increase in your quality experience from about an 8.6 to about a 9.5, and as sort of a side benefit of having made that happen, you get an increase in the next variable placed for someone like me from about an 8.5 to a 9.4 because these are interrelated. These have joint probability. If you can then push that one a little further to 9.5, you get a concomitant further increase in your target variable mean, and so on as it ripples through the process. Okay? And the fact that this is laying it out very clearly, again, keep in mind, this was all about prioritization. Right? We can't focus on all these things at the same time. What subset should we be focusing on? We've achieved that prioritization because this is the order in which you want to focus on these. In your product development or in your services design, your marketing communications, these are the perceptions that you want to be enhancing in the marketplace in order to move the needle on that target market outcome that you cannot directly influence, but that you must influence if you're going to be successful in achieving your business objectives. And down here, don't worry so much about these. Okay. Yep. These turned out to be your true just-in-case attributes. Right? These are the ones that matter. This is very, very useful and actionable knowledge for somebody who's trying to raise market share points by 1 or 2 points will make a difference of millions of dollars. Okay. Multicollinearity no longer a problem. In fact, from what Stefan tells me, it actually kind of helps almost a little bit, or BayesiaLab can actually kind of leverage it to some extent. And you now have indirect interaction effects included in the model. You haven't settled for a series of bivariate regressions. I had to laugh when Alex used the term "so what" a couple of times. We actually have this trademarked. I'm not kidding. You see, look, right there. We are the so what marketing research firm. We worry about the so what. We often joke, be careful about what catchy phrases you might mutter around our CEO, because he might have a trademark by the next day. But this one has been with us a long time. So, thank you very much.